Welcome. In this video, we will solve problem longest palindromic substring asked by companies like Amazon, Microsoft, Facebook, Apple, and many others. Now let's check out this problem longest palindromic substring. Okay. So if you have seen my previous videos, I have solved couple of problems on palindrome. How to find palindrome, valid palindrome. We have discussed different variations on it. Okay. So I hope you are clear with the concept of palindrome. What is a palindrome? Okay. But let's before starting this, let me give you a brief idea about palindrome. So basically, a palindrome is a set of characters or letters which reads the same when you read forward and backward. So for example, I have one set of characters like madam. So if I read from frontwards, so it will be M first letter, then A second, then D third, then A fourth, and then M fifth. Okay, but if I read from backwards, right? So it will be first letter M, then A, and then D, and then A, and then M, right? So you can see in forward and in backward, both are like both characters read the same. So that's why this string is a palindrome string. Okay. Okay. So what is the question? In a given string S, we need to return the longest palindromic substring. Okay. So longest palindromic substring. So here are some examples. Let's quickly understand the examples. So we have BABAD, right? So if I'm taking here BABAD, so if you can find the palindrome here, so we have this BAB and we have this ABA, right? Apart from this, is there any other palindrome? No, right? So we have two palindrome only, and the maximum length of the palindrome here, that is 3, right? So BAB and ABA. So we need to return the longest palindromic substring. So we have BAB is the longest palindromic substring. Now you can ask me, right, why we have not written ABA, that is also the of same length, right? But suppose if there are two strings, first and second, in this problem we are returning the first one. Like if you find the first one, that is palindrome, you are returning that one. Okay. Let's check this case CBBD, right? So this is the only string that is palindrome, right? Substring. So I will return BB, and here the maximum length is 2, and here the maximum length is 3. So in these two examples, do you found any difference? Like, is there any sort of difference? Yes, there is a difference. So the first one difference is like in BAB, right? This is an odd palindrome, not odd palindrome, like you can say odd string palindrome or odd length palindrome. So what is the difference between odd and even length palindrome? Basically, in odd length palindrome, you will find that there will be one character that is of single frequency. Like here, A has a frequency of 1, right? And rest all the characters will have double frequency, right? Double or more than twice, right? So I can say there will be one character that has an odd frequency, right? There will be sure that one character that has an odd frequency, and the other characters, all the other characters will have even frequency. So if I can give you an example is, let's suppose triple C here and B here, right? This is also an odd length palindrome, right? Where C has a frequency of 3 and B has a frequency of 2, right? And that's an C odd frequency and B is even frequency, right? So what was this case when we have double BB? So basically this is an even length palindrome. So here the B has only two frequency, right? And suppose like A, then we have B here and C here, right? This is also an even length frequency where each character A, B, and C has even length, even frequency. Okay. So this was a short idea of odd length palindrome and even length palindrome. Okay. Now let's see how we can solve this problem. So let's take a couple of examples to understand it much better. So suppose we have one string. Let me use a different color. We have one string, and let's suppose we have A, C, A, then B, and then I have A, R, E, R, A, B, B, A, R, let's suppose. Yes. Here, what are the different palindromes we can see here, right? So one of the palindrome is ACA, okay, and one palindrome you can see that is ABA as well, right? One palindrome is RER, right? One palindrome is from BA, not this one, like from ARER, right? This is also one palindrome, right? And if I say from here to here, from B to this B, we have one palindrome, right? Reb here, E here, okay. And if I say about the longest palindrome, you can see longest palindrome is maybe B to B, and we have also one palindrome from RAB to BAR. This is also one palindrome, right? So here are couple of palindromes, right? ACA, BARERAB, right? This is one palindrome, A to A, right? And then RAB to BAR. But which is the longest palindrome that we need to find? So I guess longest palindrome is three, like this one, BAR and RAB 336 and 17. So the maximum length I can see here, that is 7, right? And here RAB and BAR, the length is 6. Okay. So I need to return here, I need to basically return the string. So here my answer will be BARERAB. This will be my longest palindromic substring. Okay. How we can find this now? How we can find this longest palindromic substring, right? So one thing, like if I come up with a very brute force, right, the very naive approach that I can think in the first, and you should also think the naive approach in the first if you are giving an interview, right? Because see, like you are giving an interview and then during interview you are come up with a very optimized approach. That is also possible, but you have a clear justification that how you processed further. First of all, you can see that I tried it, I got it, that's a brute force approach, the time complexity will be higher, then I find out the next approach and then next, and this is my approach, the optimized one. Okay. But yeah, always start with the brute force, and before starting, always explain that this is the brute force that you are thinking about. So see, one approach that is the brute force approach is can be that you can generate all the possible substrings, right? So if I say my approach one where I will generate all the possible substrings, all substrings. So if I generate all the substrings, it will be A, then AC, then ACA, then ACAB, then ACABA, and so on, right? It will go till here, then it will be C, then CA, and CAB, right? Then CABA, and similarly, then now I will start from this A, right? It will go on, right? So it will basically, I will generate all the possible substrings. Okay. And this will take how much time, right? This will generating all possible substrings, right? We know that it will take big of n square time. Once you have generated all the substrings, right? This is your substring, this is your substring. What you will do, you will pass this substring into palindromic function. So the next thing you will do, you will check palindrome of each substring. You will check palindrome of each substring. So basically, suppose you find out this ACAB as a substring. So you will simply pass this ACAB into your palindromic function, and where you will check that this is a palindrome or not. You will take L pointer that is pointing to 0. You will take R pointer that is pointing to n minus 1, where n is the length of the string, your substring, right? So basically, we have solved this problem, right? So we have A, then A, so both are equal. So what I will do, I will move my L pointer here, I will move my R pointer here, and here I have found C, and here we have B, so I will return false. So basically, your pointer, your palindromic function will return true or false, right? Now, if it is a true, what you will do, you will store the maximum length, right? Maximum length of the substring, or you can see the maximum length string or max string you can store there. So suppose, like similarly in anything, you suppose first find out RER, right? and then you find out that ARERA, that is also a palindrome. So you will store this one, right? And then you find out that we have BARERAB, right? Then you will store this one. So this is how you will basically store it, right? So let me write the third and last step. Basically, you will check palindrome, and if it is returned true, we will store the substring, right? So this is one approach. Let me give you a quick idea of the pseudocode, how you can write the pseudocode of this approach. So pseudocode will be, so basically what you will do, you will start one pointer from I0 to s dot length, right? And then you will take one more pointer that will start from j equals to I to s dot length, right? Your string dot length. And then what you will do, you will simply generate a substring, right? So you can also generate a substring like simply by taking one variable. Suppose like here, if I say you can take one variable that is temp, right? So here you can initialize temp with an empty string, and you can simply add your sj to it, and you will simply check for a palindrome. That is also one possible. Or you can call an inbuilt method, right? That will also with the same time complexity, so there won't be any change in the same time complexity. The code will be a bit more nicer. So suppose this is my substring. How I will calculate a substring? I will simply call inbuilt method substring, right? Where I will pass the indexes. So basically what I am doing, I am starting from I am going till j plus 1 to find out all my possible substrings, right? So suppose we have one string b, right? So suppose my I pointer is here, my j pointer is here, right? So it will simply start from I, b, a, b, it will find like this, right? And then what I will do, I will check if it is a palindrome or not. So this is my palindrome function. Let me choose a different color. So I will simply say if is palindrome, right? So I will pass this substring, right? And I will check, right? If the substring length, because length should be higher, then I will take into consideration if substring length is greater than the longest string that I basically stored as of now. So I will simply update it. So I will basically update it. This be like this, one closing of this bracket, right? Then we have a closing of two for loops, right? Here what I will do, I will simply say longest equals to substring, substr, right? And in the last, what I will do, I will simply return the longest, right? And is palindromic function, you know how to find is palindrome, right? We have solved, I guess, this problem only, how to check a palindrome or not. So yes, this is how you can find. So here this loop will run for n times, this loop will run for n times, right? And this is basically run by on single times, right? So this is not countable basically, right? If you start from I and you are going till n, then it will run for n times. So basically it will run for only to this string. And is palindrome, right? This will also run by n by 2 for each things, for each substring, and the total time complexity will be n square for generating substring, and then n by 2 for checking with the palindrome. So the time complexity will be n cube by 2, and if I say overall time complexity will be big O of n cube. This will be the time complexity, and space complexity will be big O of 1 because we are not taking any extra space here, right? So this will be time and space complexity. Now, this is one of the approach that you can apply, that you can simply say in your, like when you are starting. Now, how we can optimize this, right? If we can optimize this problem. So let's again quickly check the same problem. So let me say that I have a string of length s, not length s, basically a string of s. We have I have character A, C, A, B, and A, R, E, R, A, B, and then I have B, A, R. This is my string S. Okay, and let me put the indexes as well: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, right? So how we can optimize the previous solution? So basically what we were doing in our last approach, so basically we were generating all the substrings, right? We were generating all the substrings, okay, and we are even checking those substrings that are not going to be a palindrome, right? So like here AC is not going to be a palindrome, we are checking for this one, we are checking for each and every case, right? So now we can optimize this. How we can? I will take one character like A, right? And if you know that there is a, like, if S length is only 1, that means that is a palindrome, because A is itself a palindrome, right? Single character is itself a palindrome. B is itself a palindrome. C is itself a palindrome, right? Any character that is of single length, right? That is a palindrome. Of single, basically character with single frequency, that is a palindrome. So what I will do, I will take A, right? A is a single character, and I will check, right? If I extend A, right? If I extend from A, will this going to be a palindrome? Right? Is it forming a palindrome? So basically, what I will do, I will send A and I will send L and R pointer, right? Basically, and I will check if I like L and R pointer here, I will move my R pointer here and L pointer here. So if I'm moving R pointer here, what is the next character? That is C, right? But here in L pointer, there is nothing. So that means A is not forming a palindrome, right? So basically what I am checking, I am saying I am finding a palindromic center, right? So let's take this example, BARERAB. So basically what I am doing, I am finding that suppose this is my center L and R, right? E, I will further extend L here and then R here, and I will check if these two characters are also equal. Yes, these are. Then I will further extend my L, I will further extend my A, R, and I will check is these two characters are equal. Yes, these are also equal. I will further extend my L and R. Okay, and whenever, like, till this condition is equal, right? When L is equals to R and I'm able to extend it, right? What I will do, I will simply store the string into some variable, right? Suppose longest. So I will store these strings like this. First I will store E, then I will store RER, then I will store ARERA, right? Then I will store BARERAB, right? And this is how, whenever this condition will break, the maximum length I will have, that will be this of length BARERAB. Okay, so basically this will be my approach. So let's see here what I'm doing. Like I checked with A, I'm not able to find it like here because C is defined, but before A is not defined. So I will move to the next character. I will check with C, right? So I will check with C. Suppose here, right? We have L pointer, R pointer here, right? Then I will move my R pointer here, L pointer here, right? And here we have A, here we have R. So basically in my longest, okay, I have was first stored A, then is stored cancelled with C, right? Not cancelled because of both are same length. Then I will store this ACA, right? So now my new longest substring will be ACA, right? Then I will further extend R here and L here. So here we have B is defined, but here L is not defined, right? You can see L cross the limit basically. L cross L is now less than 0. Okay, that is a false condition. The longest so far I have achieved, that is ACA. Okay, not ACR. Then I will further move ahead, right? I have A. So I will check with A again. We have L pointer, R pointer here, right? If I move R pointer here, I will find out B. If I am moving L pointer here, I am finding out C. That is not equal, right? So I will simply move ahead. I will check with B, right? So if I check with B, L pointer, R pointer here, I will move R pointer here, so it will be A. If I move L pointer here, it will be A, right? So again, same length, right? So I am not going to change it, right? I will move ahead. R pointer will be here. I am finding here R. L pointer will move here. I am finding here C. That is not equal, right? That is not equal. So I will simply discard this case. I will move ahead, right? I will check with A. Similarly, A also won't give me the answer because here we have B, here we have R. Then I will check with this R. This will also not going to be giving me answer because I will start with R, and here we have A, here we have R, E. So that is also not going to give me answer. Then we have E. So now let's check with this case. Okay, this is an interesting case. So far I have the maximum, that is AC, right? So I got here E, right? So I will store E, and let's differentiate between E and L. So this is my E and this is L and R, right? So now what I will do, I will move my L and R pointer here, L pointer here, R pointer here. So I have R here, and here I have also R. Okay. Again, is this the length here that I am getting RER is equals to ACA. So I am not going to change it, right? Again, I will further move my R pointer, further move my L pointer, right? So here, if I am doing the same, here I will get A, here I will get A, right? And that is also equal. L and R both are equal, right? L pointing to A, R is also pointing to A. So now this is a big length from the previous that I have stored. So what I will do, I will store this one. I will say ARE, right? I will store this one. Again, I will further move my R pointer. I will further move my L pointer. Okay. And here we will get B, and here I will get B. And here, like both, like L is pointing to the same character, R is also pointing to the same character. So I will store this one as well. So I will store BARERAB, right? Again, I will further move my R pointer, further move my L pointer. So here, if I'm further moving ahead, B, I am getting B, and if I am here moving ahead, I am getting A, and that is not equal, right? Here it is not equal. A is not equals to B, right? So the maximum length I have stored as of now, that is BARERAB. Okay, now what I will do, I will simply move ahead, right? I will check this case. Here E and R, we have for in the left of R we have E, in the right we have A. So not going to happen. RAB not going to happen. Here it's not going to happen. Now see, we are losing this case, right? If you can see, right, here I am finding B, right, and I am passing L and R character. So here in R I have B, right, and here we have A, right? Here we have A. So this is not a center of my palindrome, that is I am going to find. And similarly, right, if I am checking the next B, right, here I have A and here I have B. That is also not center of the palindrome, but this is a palindrome. So you can see my approach is well defined working for a odd palindrome, right? For an odd palindrome, right? Odd palindrome, we are checking with the same character. Like here we have checked with E, then RR, then AR, but it's not working for even palindrome, right? So what we will do, we will find out for even palindrome as well, right? So basically what we need to do, if I need to find even palindrome, so on each character, like here, on each character A, what I will do, I will pass the next character as well in my even palindrome, right? So basically in the same palindromic function, right? So suppose here, let's take this example, C, A and A, right? I started with A here, and both L and R was pointing to the same character, like same index. So L was 1 and R was also 1 here, right? But what I will do, I will check for, this case for odd palindrome, right? Now I will check for even palindrome as well. So what I will do, my L pointer will be same, that is 1, and my R pointer will be simply I plus 1, I will say, so it will be 2, and I will check it. So see, if I am at this B, right, and if I am forming this, checking this one, so how I will check it? So suppose I am at here. So if I am taking this case, my L pointer is pointing to the 9 index, and my R pointer will be L plus 1, you can say. So it will be pointing to 10, right, 9 and 10, and then I will check it. So basically what I will check, my R pointer is like my L pointer is pointing to this B, R pointing is pointing to this B, and I will check. Okay, B and B both are equal. Yes. So my R pointer will move ahead, L pointer will move ahead, and I will check. A and A both are equal. Yes. What I will do, I will move my R pointer, I will move my L pointer, then I will check. R and R both are equal. Yes, both are equal. So what I will do, I will again, my L pointer will move ahead, my R pointer will move ahead. And if I am moving here, I am getting out of the bound, right? So you need to also check that are you going out of the bound, out of the bound. So few observations from here, this example, if I write down the observations here, or let me make this one and let me write the observations here. So first observation is, right, because this observations will help us to write the pseudo code, right? First observation is I will start from I, right? And I will simply go till n. Basically, I will take each character, right? So this is for each character. I will check, right? First observation. Second observation, for each character, I will check the two cases, right? First, odd palindrome case, and even palindrome case, right? So for odd palindrome case, right, your L pointer should be at I and your R pointer should be at I, right? It will start from here. For even palindrome case, your L pointer should be at I, but R pointer should be I plus 1, right? This for even palindrome case. This is third observation. Okay. Now, fourth observation is when you are checking for it, when you are checking L and R, your L should always be greater than equals to 0, right? Because you are basically starting, suppose you are starting from here, right? L pointer, and you are further moving here and your R pointer is moving here, right? Basically, you are going here in this L direction and you are going here in this R direction. So L should be greater than equals to 0 always, and your R should be always less than the S dot length, right? It should be always less than the S dot length. Okay. Now let's talk about some extreme cases. Okay. Suppose one case is like, suppose we have one string and I have this as a case A, B, M, R, right? Is what is the longest palindromic substring here you can find? That is A and A, right? So basically, when you are taking this one, when your I pointer is here, so what you will pass, your L pointer will be I and your R pointer will be I plus 1 and you will check it, right? Similarly, if I take another edge case with the similar, I can say B, M, R here and A here, right? So suppose you are at here, your I pointer is here. So your L pointer will be at I, R pointer will be at I plus 1. So basically your R will point to this one and L will point to this one. Okay. Now, when you are pointing this one, I guess you don't need to reach to this character, right? Because if that is a single character, suppose like in this case, B, M, R, A, right? If there is a single character, so that is only a single character palindromic. So you have already find out the single character we have here. Okay. If that is an odd character, like if this is a palindromic, like even character palindromic, right? So you need to reach to this length only, because if this is L, right? This will be your R, R will be your I plus 1, right? So if suppose you are checking here, if you are checking here, right? Odd case, the L pointer will point to I and your R pointer will be I plus 1, and which is undefined here. Okay. So let's see BMR A and index is 0, 1, 2, 3, 4, right? And if your L pointer is pointing to this character, your R pointer will be pointing to I plus 1. Basically, here somehow 5, but 5 is not defined. So you will get an undefined error. So you won't reach till here. Your I pointer will start from 0. Your I pointer will start from 0 and it will run till n minus 1 only, right? So your L can be become this one, right? Your L can be your second last character, so that your last character can be R. Okay. So basically, this is one of the observation, right? that my I will be not from starting from 0 to n, it will be 0 to n minus 1, right? And remember this condition. Okay. So yeah, this will be our approach to, right? And now let's quickly check the pseudocode of it. So what will be the pseudocode? So basically, let me write here the pseudocode. So basically, if suppose getting any length of s, okay, that is less than equals to 1, can I directly return the same character, right? Because if suppose you are getting only a, so a is an answer, right? Then what I will do, I will simply start a for loop that will start from 0 and it will go till s dot length minus 1, right? I will start from here to here, and then I will take two cases, right? I will take an odd case, right, and even case. Okay. So in odd case and even case, both the palindromic function will be same. Suppose check palindrome, right? In one case, I will pass my string, and basically because the whole string will be calculated, and I will pass the I pointer as an L, and I will pass I pointer as an R, because in odd case, right, both pointer will be same. The next function, right, when we have check palindrome, same function, right, I will pass S and I will pass I and I plus 1 for even case, right? And suppose here, if your odd case, because this will return the length, if your odd case length, right, is greater than whatever you have stored in max, right, max dot length. So what you will do, you will simply say max equals to odd case, right? And suppose if there is one even case, and even case length is greater than your max length, what you will do, you will say max equals to your even case. Okay, and then in the last, what you will do, you will return maximum. So here you will return maximum. Now the next thing is how you will figure out what is this check palindrome, right? How you will check if this is a palindromic or not. So here will our check palindrome function. So let me write it here. So I can say function check palindrome. Okay, where like it's too close to that side. Let me copy this, shift it here. Now let's see. We have one function. Okay, before there, let me here define the max also, because I'm checking with max. Max I have not defined. So max will be like your s. You can say suppose your s0 can be your max, because you are initializing, right? You can start with your first character. So s0 is suppose max, right? Here your function will be check palindrome. So you will check palindrome, you will pass S, L and R. These will be the three parameters, and you will check while, right, L is greater than equals to 0 and R is less than S dot length. What is the condition? That S of L, basically your L character and R character should be same. So S of L should be equals to S of R, right? When these three conditions, right, these three conditions are true, what you will do, you will run the loop. You will run the loop, and what will be inside the loop? Inside you will simply run L minus minus and R plus plus, right? You can run it like this. And whenever you will come from the while loop, right, you will return basically the substring. So you will return as S dot substring that will be from your L plus 1 to R. Basically your, because suppose you have out from the string. So out from the string, basically, let's take this case. So suppose we have one string B, A, B, and here R and here M, right? So your L and R pointer started from here, right? Then R pointer will move to here, L pointer will move to here, and now L pointer will point to M and R pointer will point to R. And here these characters are not equal, right? characters are not equal. So what you will do, basically, you will say substring from L plus 1 to R. So it will give you from BAB to R. That means this. So basically it calculate from 1 minus 1, right? So it will calculate BAB, like from B to B, right? So basically, if I am writing MABR and these are my indexes 0, 1, 2, 3, 4, and if I am passing that L plus 1, that means I am passing 1 and I am calculating R till 4. So 1 to 4, so it will calculate till this one because it always calculates till R minus 1, right? The second character minus 1. That's why if you can remember in the first approach, we have done I to J plus 1 because I want a substring that is starting from I and going till J. That's why I put it J plus 1. Even if you don't want to do this substring thing, right, what you can do just after the while loop, you can simply start from your L pointer, right, and you can run till R pointer and you can simply calculate by a single for loop. That is also possible. That will run for L to R. So what will the time complexity here, right? So basically here this will run for n times your for loop, and here this while loop will run for n times. Even if you are counting this one, suppose you are taking one for loop, that was also nearly not equals to I guess n, that was also nearly suppose n. Even this also time complexity will be big O of here for each, because you are checking check palindrome, right? N and n here. So n by 2 this one, n by 2 this one, right? So it will be again n2 n square, right? And the time complexity will be big O of n square overall time complexity, and the space complexity will be big O of 1. You are not taking any extra space. Okay. So yeah, this will be our second approach, and this is the most optimized approach. Okay. If you want to further optimize, there is one approach that you can apply. Like I am not giving a DP solutions of it because, right, if we are going to a DP solution, we will get a time complexity same to big O of n square, right? And then we will get a space complexity of big O of n square, right? So that is not a way, right? Suppose you have explained this second approach and you are coming with a third approach, the interview might be think like you will come up with an optimized approach, right? But you are not coming with an optimized approach and you are saying that here time complexity will increase, then interviewer say like what you are doing basically, right? What is this thing, right? Why you are wasting my time? Okay. So then, like if you want to further extend this, there is one algorithm that I want you to explore. Okay. If you want, I can create a video on it, right? That is Mencher's algorithm. So basically, in Mencher's algorithm, right? You can search of it. It's a bit of complex algorithm, right? Same thing that we did in the second approach, right? We will here also start within center, right? In Mencher's algorithm, we will here start within center, and we will find out that what is the palindrome that we got. So basically, suppose we have BAREARB, this the palindrome we have find out. What I will do, I will simply note down the possibilities of the next palindrome, and write suppose RAB, this is in the left. So I will figure out that is this center is going to be a palindrome or not. Basically here what I am doing, here I am checking each character can be a center of my palindrome, right? I am checking each character can be a center of my palindrome. But in Mencher's algorithm, basically if I find out a palindrome, right, I won't check the each center, like each character will become the center, right? Because see, suppose you are at R, right? This is your center of the palindrome. So E is not going to be a center of the palindrome. Like suppose E is your center of the palindrome, then R is not going to be a center of the palindrome, because if it is a center, then this should be give you the maximum palindrome, right? Right? If A is center, then this A should give you the maximum length of the palindrome, right? So by this thing, Mencher's algorithm work, right? You can apply this Mencher's algorithm, you can test it out. The time complexity here in Mencher's algorithm, you will get big O of n, right? But we will also, because we are storing in a DP, then the space complexity will be big O of n, right? But that is not like generally asked in the interviews, because Mencher's algorithm is quite of complex. Even if you are describing it, right, it will take a lot of time to understand, right? So you can check out Mencher's algorithm, right? And apart from this, you can go with this approach, you can submit it, you will get the answer, right? So that's all about my longest palindromic substring, right? I hope you got the solution. Okay. In the next video, we will talk about more such problems. Okay. Thank you and have a nice day.